Hi, I'm Jim Pomerantx, professor of psychology at Rice University and a researcher in the area of human vision. And I'm here to tell you today about an illusion called the rubber pencil illusion. And essentially it goes like this. You take a regular wooden yellow pencil and put it into motion. Let me put a black surface up here so that you get a little better contrast in the background. And you put it into a certain kind of motion and the pencil then appears to go rubbery. And the question is, why is it that that happens? Well, let's start out by reviewing a couple of things that we've learned about vision over the years. One thing that we've learned is that we don't see the world in real time. There's actually a measurable lag in our perceptual experience of the world, which is probably attributable to the delay that it takes in our neurons, our brain cells, conveying information from the eyes where it's first received to later brain centers where it's interpreted and converted into conscious perceptions. But also, our visual system produces after images, where what we're seeing at any one time is in part determined by what it is that we're actually looking at that instant, but also in part by what has gone before. And so when a flash bulb goes off in your eyes and you see spots for a few minutes, that's an example of an after image. It means that the retina, light-sensitive cells in the back of the eye, are sending signals to the brain that are based on what the eye saw sometime earlier. So if I put my hand into rapid motion before my face, you can see my face through the hand movements, even though at one instant in time, my hand is probably blocking out my face entirely from your perspective. But if the motion is quick enough, we can see what appears to be a continuously visible face through the motion pattern. And notice, too, how you can see an entire envelope of all the areas in the image where my hand is put in motion. In fact, if I were to trace out a circle with my hand, you can kind of see that circle. And as I move more and more and more quickly, there would be a moment in time where you might be able to see the entire circle. Not because the hand is in all places at one time, obviously it's not, but because your visual system is so slow. So when we put a pencil in motion, if we move it quickly enough, then you can see the continuous background through a veil. That's the way it appears. But you notice that the brightest areas are at the very top and the very top and the very bottom of the excursion, where the pencil's dwell time is longest. The pencil stays in one spot for a moment. It comes to a halt at the top and the bottom, and so you get a nice dark, contrasty region. Now, when the pencil is put into the kind of motion that yields the rubber pencil illusion, those areas of maximum contrast, where the regions of the pencil are the most stable, producing the highest contrast, those points actually define smooth curves. And that appears to be the reason why the rubber pencil, why the now straight pencil, appears to the human visual system to be rubbery. Were our visual systems faster than they are, were we to have the visual systems of certain insects, for example, that can see flicker at a much faster rate than the humans are capable of, we would not see the rubber pencil illusion at all. So this is another instance where an illusion, an error in our perceptual system, if you will, tells us something fundamental about how our perceptual systems work. So thank you for watching. This is Jim Pomerantx, and watch for my other videos explaining fundamental effects in human visual perception. Thanks.